I love Paris in the...
Well, part 4. Time to put it all together. All the waves, all the Paris, all the line segments, from all, or from a manageable 15 points, like these two. We need not a square wave, or a triangle wave, or a sawtooth wave, but a this wave. A wave that is 0 everywhere, except when it's not. From point 1 to point 2. Cue the equations. Slope, intercept. Why? Because y equals mx plus b. Battle stations, we've been here before. First step is a naught. Long and cumbersome. Not a cute, satisfying result, but that's a good thing. That means we keep all the information. T, R, U, S. Wait, where's U and S? There, hidden in M and B. AN, I must admit, I'm a little nervous. Break it into 2 parts. Integration by parts on part 1, and the result of that, and part 2 of AN is shorter, and the rest of that, and AN in all its glory takes more than 1 line. That's the mark of a good equation, and BN in its glory is basically the same thing. 2 parts, integration by parts, and I said it's basically the same thing. Well, what's different? AN versus BN comes down to cosines and sines, negatives and positives, on and off switches, and that's what we want our wave. We want to be able to control our wave. Well, anyway, if you thought solving this was fun, which you probably didn't, just wait till we graph it, and you'll have to wait because I want to show you first that it works. Hey, it's this thing! It's the thing I promised to do in the last part of the video, and there it is. It's the intermittent triangle function. It's the row of sharks type function, point 1 and point 2. This one is closer to what we'll need to map Paris. Up or down, and yeah, it's not very clean. There's bumps here. I only went out to n equals 5 terms here, and wait, what happens? What happens if we push R and T close together? We did this in the earlier video too. Narrow peak, we lose some amplitude. A lot of slope information too. We basically have no slope information. Well, maybe we have a little bit there. It's asymmetrical. You admit that it's asymmetrical, and we're going to have to be satisfied with that anyway. No putting it off any longer. Time to put it into a spreadsheet. Information from these 2 points. Things to tweak, equations for slope and y-intercept. Notice L here, it's the window size again, it's 250, and we're going to graph from x equals 0 to x equals 500, or x equals 2L. Translation. We are getting just 1 wave cycle here, so no peeking into our neighbors this time. Remember A naught? Well, we have columns for these guys. And what about those guys? Well, it's not pretty. But some of these pieces are repeated. And those pieces are repeated too. Watch your negatives and put it all together. And when you do that, don't forget the cosine n pi x over L term and the sine n pi x over L term. That's the big deal of this whole thing. That x only shows up inside the sine or inside the cosine function. R, S, T, and U, they are all over the place. But X is not. Still, it's a pretty big spreadsheet, especially if you carry it out to n equals 7, which is what I did, but Paris is worth a massive amount of spreadsheet columns. And that officially was the worst pun in human history, a joke aimed directly at you if you were a person who's into Fourier Series and also French monarchs from the late 16th century. Anyway, line segments, 1 by 1. 1 as a wave. 2 as a wave, 3 as a wave, 4 as a wave, 5 as a wave. And I'm getting a little bit nervous about these small amplitudes, but we're just going to have to hold our breath until we can add all these waves together. 6 as a wave, 7 as a wave, 8 as a wave, 9 as a wave, 10, 11, 12. Again, why such a small amplitude? 13. Oh, that's why. That's why. It's because of the narrowness of the peak. A narrow delta x lowers the amplitude. Okay with that. 14 as a wave. 15. And are we ready for the big reveal? Here it is. I was thinking of going to the internet and downloading a file of a sarcastic golf clap, but then I figured I could make my own. Time to declare victory and wave goodbye, or au revoir, because in the next video I'll try to tie this back to those more impressive epicycles.